Good afternoon, everyone. My name is Yoshie Takao. I'm a fourth grade student of undergraduate. Today I will talk about the correlation between serum vitamin A level and pupil color of beef cattle. Some of the contents is same with Hansan, but please listen. First, let me introduce the background of my study. In the world, especially Japanese people are particular about food quality and safety. And of course, there is a big demand for high quality beef. Look at the picture. Both of them are Japanese black cattle's beef. You can notice that right beef has much more fat deposit position. This white position, this is called marbling. And Japanese people like high marbling scored beef. So we can say that high marbling score means high quality beef. And farmers usually try to make effort to produce such a beef. Then what should we do to make high quality beef, high marbling scored beef? The best way is to control vitamin A level like that. Look at the graph. This graph shows the ideal vitamin A level shift. And different fatting phase needs different fatting level. Control vitamin A like that, we can produce high marbling scored beef. But in order to do that, we have to monitor serum vitamin A level constantly. So far, farmers conduct broad tests for measuring, but that way is not good because that is very stressful for cattle and high cost and time consuming. So another measuring method is desirable. And recently, some researchers report the relationship between vitamin A and eye ground color. Look at the picture. This is a picture of retina. Eye ground, part of eye ground. Retina is this part, this red part. And we can notice that the retina of low vitamin A level cattle has something wrong. So this report says if vitamin A level becomes lower, blue part of retina becomes red or yellow. But retina is eye ground, so that part is difficult to take image. On the other hand, pupil area is very easy to take image, and there is a hypothesis that pupil color is influenced by retina color. So we start to take and use pupil color image. The objective of this study is that developing more practical method of serum vitamin A level measurement by analyzing pupil color image of cattle. And we want to create new vitamin A measurement system. From now, I will explain about test cattle. Explain about experiment. First, test cattle. For this study, we used Japanese black cattle in early fatting phase. And we started this experiment with 24 head of cattle. From March, another 18 cattle were added, so the total number of cattle is 42 now. And this is a device we use for experiment. Main component is 2CCD camera. And by using this camera, we can take the two types of image. One is color image, and another is NIR image. And we attach the PL filter, polarizing filter, in order to weaken specular reflection. Here is the method of experiment. Before starting to taking image, first we cover the cattle's eye with black cloth to dilate pupil. It takes more than 120 seconds. And after that, we put NIR LEDs on and set camera to pupil position. And after that, put white LEDs on and start to input images. It takes just 3 seconds. And after that, we got color image and NIR image at the same time. And by using that data, we analyze the data. And here is the method of analysis. For analysis, we used programming. This picture is the raw data. And from this data, binarize image using R, B, hue, and IR component. And after that, reduce noise and detect hallucination part. And ROI, region of interest, is determined. And about ROI, we got mean RGB values. And by using mean RGB values, we calculate chromaticity values and HSI values. Here is the formula of chromaticity values. We got small r, small g, small b. And about red, green, blue, and HSI value, we made a graph. So from now, I will show you the result of my study. These are the scatter diagram of the red component and blue component. And about red, red has a negative correlation in 38 cattle. On the other hand, blue has positive correlation in 35 cattle. So there are correlations between red, blue component and vitamin A level. However, there is a problem. Sometimes the same color level indicates various vitamin A level, so we cannot estimate the vitamin A from only these data. So I start to make time series data about each cattle. This is a graph of time series data about red component. X-axis is the experiment months, and left y-axis is vitamin A, and right y-axis means red component level. And I picked up only 4 cattle, but I picked up only 4 cattle, and there's some individual difference, but almost all cattle has the tendency that if vitamin A becomes lower, the red component becomes higher. So we can say that red component oppositely changed with vitamin A. And next, these are the time series data about blue component. And this time, I also picked up only 4 cattle, but almost all cattle has a tendency that if vitamin A becomes lower, the blue component also becomes lower. So this means blue component similarly changed with vitamin A. And this is a previous result. Last year, by using middle fatting phase cattle, same experiment was conducted. These are the data of at that time. And this time also red component oppositely changed and blue component similarly changed. So same tendency was found in 80 cattle at least, also last year. And let's go back to this year's result. This is a scatter diagram of hue and intensity. And x-axis is vitamin A and y-axis is H and I. H has a positive correlation in 34 Kado, and intensity has a negative correlation in 31 Kado. Hue has a positive correlation 34 Kado, and intensity has a negative correlation in 31 Kado. And also, R squared value of H and I are higher than that of red and blue components. So I think considering about the H, hue and intensity is also effective in estimating the vitamin A level. So here is a conclusion. If vitamin A becomes lower, red becomes higher, and blue becomes lower. And so there is some correlation. And in addition, hue and I also have correlations with vitamin A. So next time I will try to use hue and intensity values for measuring. And do you believe the picture I showed you at the background? These are the picture of retina, eye ground color. And at that time, the report says the raw vitamin A, if vitamin A becomes lower, the blue part of retina becomes changed to red or yellow. And our conclusion is correspond to that report. So I think that our hypothesis that pupil color is influenced by retina color is maybe right. That's all for today. Thank you very much.
Just one thing. When you pointed by laser pointer, still you felt that's some kind of acrobatic. When you pointed to
Yes, yes. Thank you.
Yeah, quite easy to understand. It's very good.
Thank you.
Some of them should be improved, I think. Number 4. These upper photos, did you explain about that on this page?
Actually, that's
Yes.
So, but first you explained that bottom.
Just indicate that. Just indicate the retina part and explain about that. Explain about that.
I missed.
Sorry.
Yeah, it's okay. Then this was those photos are some more information, hopefully necessary. Because which one is lower vitamin A, which one is higher vitamin A. This was open the eyeball when slaughtering.
First here, but after that I consider that's not good though. Maybe.
Then
yes, I try to include that.
I found some caption on the y-axis. That would be the opposite. Some R or B. This is like a Q. Q should be B.
Yes.
Very opposite.
Here.
Yes.
Like that. Okay.
Left is up.
Thank you.
If you do, but yeah, you can do upright just a bit.
This is me.
Just normal.
Here.
Just upright.
This one.
Yeah, if you can.
Okay. I can.
And conclusion is that a little weak. Maybe. Also, maybe a little bit more scientific. Some other terms and just maybe more.
Yes. Okay.
That is what I.
Can I go back into your second slide of objective? That's a very important slide when you come up.
Objective.
To develop a more practical method for serum vitamin A measurement by analyze purple color, you have to indicate what's the reason behind this. Are you trying to develop a method to be able to look at the eye for vitamin A concentrations, or you want to develop a technique to alert the farmer when the vitamin A is below 30? That makes a very big difference how the experiment is being done.
Yes.
A completely different objective. One is develop a method to be able to measure the vitamin using the pupil color to determine vitamin A concentration from 20 unit to 100. That's one measurement. You don't really need that. But what you need is a method when the farmer say, oh, your cattle now vitamin A is below 30, you have to do something.
Yes.
So what you need to do is that is completely different experimental design. So you have to ask the question, what method do you use? What are you trying to do? Are you trying to develop a method to be able to look at vitamin A concentration at a wide range? Or are you trying to develop vitamin A concentration at the level the farmer needs to be doing something? Someone will ask you that question to me.
Yes.
What do you want to accomplish?
Accomplish. I want to accomplish. Yes. Both of them. Just one.
The interpretation of the data is totally different. The reason why, then go back to the result section. I want to tell you how we look at the result. Yes, right here.
Here.
Go back. This one. You show this plot, for example, the first one. You show the vitamin A concentration from 30 all the way to 80. Very broad range.
Yes.
Very difficult to look at data that broad range. However, if you say, I would like to determine if my method can alert the farmer when the purple color reaches a certain stage, the vitamin A is below 30. Then you analyze the data only from 35 on down.
Borderline, but there's a problem. There's a few cattle under the 40.
So very important, because in your study right now, very few cattle, only one cattle have vitamin A below 30. All of them about 30. So that means is that your experiment, your cattle really is not good for you to detect lower range.
Yes.
You understand? Very important. That means is that you don't really have enough animal with the vitamin A below the level that I should be concerned with. So the data is very inconclusive. Because you only have one animal have vitamin A at 30, right?
Yes.
Only one data point. The other data point doesn't mean any much to me.
Yes. So what should we do?
Very important in your objective.
Objective.
It's really important to tell people what my objective. Am I to develop a method to able to look at vitamin A concentration at the right range, or am I going to develop a method to alert the farmer when vitamin A is low? The experimental design is very different.
Yes.
Is very different.
Just borderline or just more precise? You mean that?
One is completely different method.
Yes. Okay.
I don't think we need a method to look at vitamin A in the right range, but I think farmers need a method to alert them when the cattle have vitamin A below 30.
Yes, yes, yes.
So what you do is, in that case, you focus on the vitamin A in cattle 30 and 40, because that is near the, and then you calculate your correlation at that narrow range.
Oh, okay. I try next time.
Because at that range you might have good data. When you look at the broad spectrum, you might not have good data.
Yes, yes.
So what your technique is a alerting technique. That means that when the farmer look at this, yes, cow 14, we need to do something about it.
I see.
That's a very important point.
Thank you very much.
Very small observation. For example, this slide, the number 347 maybe is not very clear. This is the number of the cattle, but maybe the audience cannot understand.
I have to.
You should better explain.
Number,
okay.
number 3, or cattle number 347.
Okay.
And then number 4, maybe you should use only English terms in the slide number 4, because there is some Japanese terms in number 4, in the slide number. Slide number 4.
Number 4. Here. Here.
Yeah.
Okay.
Also, a suggestion on slide 11.
Level.
I'm sorry, 10.
10.
So for example, without GHB, what you see is without image analysis.
Image analysis.
It's the result of the image analysis, and I look at the R factor, the G factor, the H factors. Result of, otherwise most of people, we don't know what it is.
Okay, thank you.
Anything else?
A couple of things there. Your presentation was very good. Of course, your English is very good.
Thank you.
But there are some style features of your English that I'd like to point out. You use the technique of asking the audience a question, which of course you don't expect them to answer. Nobody's going to jump up and say, yes, I know. Maybe instead of saying, do you know about marbling score, you just tell the audience what marbling score is. And do you remember these pictures? No, you just go back and say, in the earlier picture, here it is.
Okay.
So you don't use that technique of asking, they're called rhetorical questions.
Okay.
Also, you used the expression picked up. You picked up 4 cattle. You didn't pick them up. You pick up
Yes.
a drink. You don't pick up a cattle. You selected or you chose.
Selected.
The question is, how did you select them? How did you choose those 4?
There are many cattle. I randomly choose the cattle for there are 4 or 5 of types of months. The cattle's age is sometimes different. 9 months, 10 months, 11 months. So I choose the 9 months, I select one, and the 10 months I select one, like that.
So it wasn't truly random. You just selected. When people use the word random, that has a special statistical meaning.
Okay.
Also, this slide here, results, plural. It's always results. Oh, you just move the slide.
10.
That one. It's always plural.
Full.
You
Plural.
with an S at the end.
Yes.
Okay.
Yes.
So you're not the only one who's done that. Materials. It's always plural.
Okay, thank you.
Test animals, plural.
Test animal.
Cattle is never plural.
This discussion is not plural. Sorry,
Okay.
it's the English language.
Test animal.
okay?
Yes, thank you.
Yes. It's okay? Okay, thank you very much.
Thank you very much.